All right, now we're looking at in section 3.5, permutations. Now, a permutation is an arrangement of a set of items in which order matters. It's really important here. It's order matters. So an arrangement of a set of items in which order matters. The number n items taken r at a time is given by the function, let's see, PNR equals NPR equals n factorial over n minus r factorial, and we will discuss what that means. So the way we write a permutation, let's get out of there. The way we write a permutation is we denote it by using a capital P and in parentheses n and r. And then this represents a subscript n in front of the capital P and then a subscript r, or this way. So this is what it means. So let's look at example 5 where it says you have 10 cars are in a race. In how many ways can 3 cars finish first, second, and third? Now in this case, it'll be different if you have the order A, B, C versus the order B, C, A. So in this case, we would say order matters, and we'd use a permutation. So this is the way the formula works. Here, n is the total number of cars, so that would be 10. And r, we're talking about 3 cars finishing, so r would be 3. So this would be a permutation of 10 things taken 3 at a time, which can be written like this, or 10 PR. And our formula would say, in the numerator, we're going to write 10 factorial divided by 10 minus 3 factorial, which of course is 10 factorial over 7 factorial. And you could punch those numbers out on your calculator to see what they equal. In fact, let's do that. So if you did it this way, you get, let's see, 3,628,800 divided by 5,040, and you get 720 different first, second, and third place combinations. Now there's another way to do this because your calculator and Desmos will perform this calculation for you. Let me show you how to do that. So here we have Desmos, and if we want to do 10 choose 40, we simply go to functions and then go right here. It's going to be 10 items with a comma, chosen 3 at a time, and you get that 720. So your calculators in Desmos will do this for you also. Let's look at our next question. In example 6, it says, the school orchestra is planning to play 6 pieces of music at their next concert. How many different programs are possible? All right. So 6 different, so we could just do 6 factorial here because the order matters. So there are 6 ways to choose the first song, 5 ways to choose the second, et cetera, et cetera, et cetera. 4, 3, 2, 1. So we could do that on our calculator, or this is the same thing also as a permutation of 6 things taken 6 at a time. Your calculator would say that was 6 factorial over 6 minus 6. That's what the formula tells us, factorial. Or 6 factorial over 0 factorial, which is where, again, this 0 factorial has to equal 1. So 1. So 6 factorial is, let's do it on the calculator. Whoops. Six factorial, 720. All right, let's look at example 7. A volunteer club has 18 members. An election is held to choose a president, vice president, and secretary. In how many ways can 3 officers be chosen? So here there are 18 members, and 1 is a president, 1 is a vice president, 1 is a secretary. So since those offices are different, we would call this a permutation also. So it's going to be a permutation of 18 members chosen 3 at a time. Go ahead, use your calculator or Desmos to find out what that is. And then we'll check it. So let's make sure we have the right share. So doing it on Desmos, we got 4,896 different possible ways to choose a president, vice president, and secretary if you had 18 people in your club. Now, another way you can do this is if you wrote out 18 factorial and 15 factorial in your denominator, because using our formula 18 minus 3 gives us the 15 factorial. The 15 all the way down to 1 would cancel with all the factors down here. So of course, what we're really just multiplying is 18 times 17 times 16. So if your calculator didn't have that function on it, you would be able to do it that way. All right, in our next video, we will cover combinations. Thanks for watching.